Hello again and welcome to another exciting video. What we are going to see the differences between the frequentist approach to the statistics and the Bayesian approach to statistics. Two different schools of thought that will basically use a different set of calculus to derive inference about the parameters in statistics. In order to see the difference, we are going to see this slide where the main features about frequentist and Bayesian statistics are shown. Okay, it's important to know the two different schools of thoughts of statistics and not only one, because at the end of the day, there are different tools that are useful for data scientists. Okay, where, for example, when we have a huge amount of data of given random phenomenon, then I would suggest to use the frequentist approach. But in the case of having like a little set of data, when I don't know, 20, 30 rows, for example, about a different phenomenon, then it could be a nice idea to use the Bayesian approach. Okay, what is the main difference? It's a philosophical difference. Frequentists regard the probability as something objective, something that exists over there. A number, okay? For example, the probability of raining today is an 80%, and this is the truth, okay? Never, on the other hand, the Bayesians think about probability as something subjective, something that it's dependent on the observer, okay? It only exists on the mind of the scientist, and it's basically a number that is estimated using previous knowledge or previous beliefs, okay? Whereas in the case of the frequentist, the probability it's independent on the observer. It's something that exists on the physical world, for like this to say. Okay, in the case of the frequentist, from an applied perspective, each random variable has a fixed set of probabilities for their events, okay, that they are objective. But in the case of Bayesians, each parameter is a random variable with a distribution, okay. In frequentist statistics, the parameter, remembers, are fixed and unknown. In the case of the Bayesians, the parameters are random variables, and their distribution depends on our degrees of beliefs. So for the frequentist, the probabilities can be approximated almost perfectly if our sample is big enough. In fact, the definition of probability for a frequentist, it's a limit. It's a limit with the sample size goes to infinity. Then I'm going to estimate the probability of a certain event under an epsilon error. Whereas in the case of the Bayesian, the uncertainty is going to decrease using the Bayes theorem as data increases. Okay, that's basically the saying of the prior is the student of the posterior. Okay, the new priors are going to be built on posteriors. For a frequentist, remember, the parameters fixed and unknown, but these features make the Bayesians see the parameters as a random variable of an observable belief. And finally, for a frequentist, the probabilities are kind of static if they don't depend on time. Okay, they only depends on the limits and they converge. This probability converges to a limit, but it's fixed. They don't vary. Whereas in the case of the Bayesian, probability is essentially dynamic. Okay, it's going to be estimated using Bayesian learning with the theorem of Bayes, and the probabilities hence. We can say it's not fixed into a number. Okay, it's just like a random variable. It's going to vary. So if you like to learn more about Bayesian statistics, I'm going to upload a set of videos where we are going to briefly describe how to make Bayesian inference with a normal conjugate model from starting from the basics, from the Bayes theorems, and I will try to make them short in order for you to study Bayesian statistics with me in the videos. So goodbye and see you in the next video.